As you and I embark together on this journey through the world of CCNA Security, which is for exam 210-260, I have a couple of tips I'd like to share with you. Number one, I would invite you to enjoy our time together. Every single nugget is going to have a lot of fun and new, exciting things in it, and we're going to be learning as we go through it together, so please enjoy the process. Another key factor for you and I really internalizing and mastering this content is to get some hands-on practice. And I'll give you the tools and techniques that we can use to build home labs to get the practice. But you know what? It's up to you, my friend, to actually do the practice that I assign. So anytime there's homework that I assign, I love it if you make sure that you do that as part of your studies to become CCNA certified and to really master this content. And the third thing I'd like to encourage you to do, and it's helped me in the past, so I want to pass it along to you as well, is I would invite you to commit. And you might ask, well, Keith, what should we commit to? And I would say we should start by committing our time. For example, maybe committing so many days a week and so many minutes a day, maybe 15 minutes a day, 3 or 4 days a week, and then commit that publicly. Go ahead and commit it to your family, your friends. Let people know that you are serious, because that'll help you with a little teeny added advantage, a little bit of pressure to make sure that you actually follow through on it. Because you made the commitment, now you're going to follow through on it. And if you want to commit to me, I would love that as well. In fact, you go ahead and make a commitment up on my Keith Barker networking page on Facebook or on Twitter and just say something like, I commit, 15 minutes a day, 4 days a week, or whatever you're ready to commit to. And then after you've made that commitment, let's get into these nuggets. Let's get into this hands-on practice, and let's really nail it. I'd like you to imagine that you and I have started a brand new company, and we have some assets in our company. We have some physical facilities, a building, we have some computer equipment, and we also have some data and personnel. Probably one of our biggest assets is our people. And secondly, probably one of the biggest assets that we have is our secrets and our data and our information that we contain. So let's say that right here, this represents our data, and we absolutely want to make sure that it's secure. So what are some of the things that we'd want to do regarding that data? Well, first of all, we'd probably want to make sure that we had confidentiality. And confidentiality simply means that the authorized people who need to see that data can see it and work with it, and then those who are not authorized to see or touch or be aware of that data can't. So we can implement confidentiality on this data by doing things like encryption. We can encrypt data on a disk, and that way if the disk is stolen or lost, the unauthorized individual won't be able to see that data. Or if we're sending data across the network, we could encrypt that data, which would provide the confidentiality. Because someone who doesn't have the correct keys to decrypt that data and see it, they wouldn't be able to make sense of that data. Another thing that we'd want to ensure about this data that we're protecting is integrity. For example, if this data says 1001, we wouldn't want that data to be manipulated by an unauthorized party. For example, if an attacker or unauthorized person was able to access that data and they changed it to 2002, does that make a difference? The answer is yes. So we want to make sure we have integrity. And that includes when we send data over a network. We want to make sure that when we send the data, it doesn't get manipulated or changed in transit. So whether that data is at rest on a disk or file system or on the network moving, we want confidentiality and integrity. The other thing we want to do, and we'll fix this number here. Let's say that data is 1001. The other thing we want to do with this data is make sure that the people who need to see it, the authorized individuals, can get to that data. And that's all about availability. Because even if we have confidentiality and integrity, if we have a denial of service attack or the authorized user isn't able to get to the data when they need it, that's a problem as far as the business is concerned. Our security objectives are surrounding these three, and CIA is a great way to remember those three terms. Now, in the assessment checks, which are almost in every single nugget in this course, here's how they work. I'm going to present a set of questions and then play some music for just a few seconds and give you time to read through them and think about what the answers are based on what we learned in this nugget together. Now, if you need a little more time than the 10 seconds or so that I provide, whenever you hear the music start, just hit pause and take as much time as you'd like to read the questions and then come up with the answers. And then what we'll do is we'll review each of them together before we close out the nugget. All right, my friend, let's go through these together. Regarding CIA, confidentiality, data integrity, and availability, which one is focused on authorized users changing data? And the part that deals with the only authorized users can change or manipulate data, that would be data integrity. Question number 2, what is one popular option for implementing confidentiality? And based on what we've discussed and talked about together in this nugget, a very popular option for protecting the confidentiality of data, whether it's on a disk or it's moving over a network, is to use encryption. So we would encrypt that data using some very popular encryption algorithms such as AES and other ones that we use all the time. And the cool thing about encryption is that if somebody doesn't have the right keys, they cannot unlock and see what that data means. And that's how we can protect data either on a disk or going over a network to make sure that only authorized individuals can see that information, which helps with the confidentiality. And then question number 3, using plain text protocols may compromise what? Now you may be saying, well, Keith, you didn't tell us explicitly in this nugget what the answer to that is. And what I'm doing here is we are reaching just a little bit together to apply some basic knowledge. So number 1, what are some plain text protocols? We're going to be covering some secure protocols in detail in this course, but some plain text protocols that you're probably already familiar with would include things like telnet, which by itself doesn't use any encryption. The data going back and forth in a telnet session, if somebody's eavesdropping and looking at that data, they can see the characters you're typing, they can see the passwords and everything else. Another application that uses plain text protocols would be HTTP. Another protocol is FTP. All those use plain text, meaning they don't have encryption. So if we use these protocols, what are we actually impacting? Are we impacting confidentiality, data integrity, or availability? And the best answer, I think, out of all 3 of those would be we are affecting confidentiality. Because an eavesdropper, if they see our password being used back and forth in a telnet session, they now have that password. Or maybe we have some confidential data that's being sent back and forth with FTP. And again, an eavesdropper who can collect all that data and see the contents of it because it's not encrypted, that now has impacted the confidentiality of that data that was being sent. So now, if someone came to us and said, what are some basic concepts we can use as we deal with and address security, we can simply say CIA for confidentiality, data integrity, and availability. Say hello to my little friend. This is a Raspberry Pi that earlier today I configured with Kali Linux. Now, the actual Raspberry Pi itself is around $35. And what I did, I added this little SD card, which acts as its hard drive, and I added this little wireless adapter, which was about 15 bucks. So all told, I probably spent around $65 on it, as you see it configured right here. I had an Ethernet cable already. And what I did, I took this Ethernet cable and I plugged it into a switch port. Now, if you haven't yet seen Kali Linux or Backtrack, you may want to check out the Penetration Testing Tools course right here at CBT Nuggets. And the flavor of Kali Linux that installs on a Raspberry Pi is very minimized. It doesn't have all the tools that the regular Kali Linux distribution has. So what I did was I used apt-get, and I installed the dsniff suite, which includes something called macOF, or macOff, however you want to pronounce that. And then I ran macOff. And what this does, it sends in thousands and thousands of frames into the switch, and it makes up a bogus MAC address for every single one of those frames it's sending in. So this poor switch port right here is now memorizing or trying to memorize all these brand new MAC addresses. Now at some point, and on many switches, a switch might support, for example, 5,000 MAC addresses in the content addressable memory. That's where it stores MAC addresses that are dynamically learned. And what happens if we pump in 6,000 or 7,000 or 8,000 bogus made-up source MAC addresses into that port on the switch? Well, at some point, the switch is not going to have room for everything. And the intent with a CAM table overflow attack is to have the switch be bombarded with so many brand new MAC addresses that it forgets about the real device MAC addresses. So maybe here on this switch, we have PC1, and on this port we have PC2. And they're happily talking to each other. And let's say that the Kali Linux box is plugged in right here. And it doesn't have to be Kali. It could be any device that's running macOff or a similar utility, sending tens of thousands of frames into the network with bogus source MAC addresses. So in this VLAN, as the switch forgets about PC1 and PC2 because of all the new MAC addresses it's learning from the Kali box, the traffic between PC1 and PC2, which would normally be switched at layer 2 based on the destination layer 2 frames. Now that the switch no longer remembers PC1 or PC2's MAC address, when the switch receives a frame and it's not in the CAM table, the content addressable memory, the switch is going to treat that frame as an unknown, and it's going to forward that frame to all other ports in that same VLAN. And that gives the opportunity for this device, the Kali device, to now eavesdrop on the conversations that are happening in that VLAN. And this is a real attack, and it's also really easy to pull off. So that, my friend, is our attack scenario. Now, what can we do to solve this? Well, port security is going to go ahead and save us. Because with port security, we could tell this port on the switch, for example, or this port on the switch, that we want to limit the number of MAC addresses it can learn on that port. For example, we could say 5. 5 is the maximum number of MAC addresses that this port can learn. And then once we exceed the 5 that are showing up on that port, we have several actions that we could take. And the violation actions are PRSS. And these are the first letters of the actions. Now, if you're taking notes, which I hope you are, and I encourage you to do so, let's jot these down together. The first violation action is called protect. Now, what does protect do? Protect says, okay, I've got 5 MAC addresses. That's the limit that I've set. Anytime I see anything more than 5 MAC addresses, I'm not going to, says the switch, I'm not going to let those frames in the network. They're not going to make it. The first 5 I have memorized, they're good. But anything beyond those 5, I'm not going to let in. Now, the problem about the option of protect is that it's a little bit shy. Now, when we think about shy, what does that mean? Well, in the case of protect, it means it doesn't want to tell anybody there's a problem. There's no syslog message, there's no SNMP, there's no alerts. It just kind of sits there and does its job, but doesn't let anybody know. And that's why we're very likely not going to want to use protect as the violation action, because we want to know about it. We want to get a syslog message. We want SNMP messages. And protect doesn't give it to us. The next option is restrict. Let's write this one out together too. And restrict does the same thing that protect does, except it's all about sending alerts and messages. So there's SNMP if you have it configured. There's syslog. The counters are going to increase every time there's a violation. And we want that information. We want to know that something's happening on our network, like an attack, like a CAM table overflow attack. So that's why we would likely use restrict instead of protect. And check this out. Not every single Cisco switch supports all of these features. We might have some switches that only support 2 of these violation actions. We might have some that support 3 and some that support 4. So depending on your hardware and the switch that you're currently on, it's possible that your switch might support 2, 3, or all 4 of these options. Now the next option, the S, happens to be the default. So I'm going to put a little asterisk next to that. And the S is for shut down the port. So it goes like this. If the maximum setting is 5 that we set it to, and that 6th MAC address as a source MAC address shows up on the port, boom, the port is brought down. It also is going to talk about it. So there's going to be SNMP, syslog, counters that are generated with that event as well. And this last S also happens to be for shutdown, but it's not shut down for the interface, it's shut down for the VLAN. And that's pretty drastic, shutting down the entire VLAN, saying, everybody stop the truck, nobody talks in this VLAN, as opposed to just shutting down the port. So the default behavior is to shut down the port if there's a port security violation, and the default maximum number of MAC addresses, once we enable port security, is 1, which means the second MAC address that shows up at the same time on that port is going to go ahead and trigger a security violation for port security, if we're using the default number of 1. Now with port security, we have 3 modes that we can play with. We have dynamic, static, and sticky, which is just a lot of fun to think about. So with dynamic, it's exactly what it sounds like. MAC addresses are simply learned dynamically as devices connect and send a frame into that switch port. So if PC1 sends a frame into the switch port, the very first frame, the switch dynamically learns that MAC address. And if this is a secure port because of port security, we now have a dynamically learned secure MAC address on that port. The next option is static. Now, what does static sound like? Well, Keith, it sounds like we're statically putting in a MAC address. That's exactly what it is. Static is where you and I go to a switch port and say, this is the MAC address that lives on this port. So, for example, if we enable port security and we have a default maximum of one MAC address, and we statically configure that MAC address, any other MAC address that shows up on that port is going to cause a port security violation. Now, on the other hand, if we statically configure one MAC address on a port and we set the maximum to 5, that means we could still dynamically learn 4 more MAC addresses and still be within tolerance. It's that 6th MAC address, if our maximum is 5, that's going to tip the scale and set off a violation. Now, I have a question for you. Let's say you and I do configure a static MAC address for port security on this port where PC1 is. So I'd like you to imagine typing the commands in to go ahead and configure static port security. And we'll demo that here in just a moment. And here's my question for you. As we press enter after we put in that configuration, where is that configuration stored? And you might say, well, Keith, here's how it works. Once we type something in and press enter, that is stored in the running configuration. Absolutely correct. So if we configure a static MAC address, it's in the running config because we put it there. And the second question is, how do we get the running config copied over to the startup config? And you might say, well, Keith, we can do a WR command or a WR mem or a copy run space start, which is short for copy running config to startup config. Any of these options of saving our running configuration to the startup config is fantastic for getting a static MAC address into NVRAM or into the startup configuration. And for the last option, I'd like you to imagine a scenario where we have 100 PCs brand new on a brand new network. And they've asked us to hard code those MAC addresses into the configuration on the switches. Oh, that sounds painful. We'd have to first of all find out what those MAC addresses are and then configure them as static MAC addresses. Well, the sticky option actually can save us some time. With sticky, what it's going to do for us if we configure the sticky option for port security is it will take any dynamically learned MAC addresses and it will automatically put them in the running config for us, saving us that step. So in that case, all we'd have to do is configure the 100 ports where those 100 PCs are connected as port security with the option of sticky, turn on all the PCs so they send at least one frame into the network. The switch would then dynamically learn those MAC addresses and it would be in the running config for us. Now that's most of the battle. The last step would be to take our running config, and thanks to sticky, the dynamically learned MAC addresses are now part of the running config, and copy that over to startup config. And once we have copied it over to startup config, the next time the switches boot up, guess what? They'll have those MAC addresses configured in them as sticky learned MAC addresses. So that's how sticky is going to help us in getting MAC addresses dynamically entered into the running config, and then manually we would follow it up with a copy run start to move them over to the startup config. Now with port security, we can set it up on an access port or a trunk port, but it does have to be a static access port or a static trunk port. Port security does not work on a port that is a dynamic port, a port that's willing to go either way. I'll go access or I'll go trunk. It needs to be configured either as an access port or a trunk port if you want port security to be used. Now, if we are configuring a trunk port, we want to be aware that we might have thousands and thousands of MAC addresses all coming over that trunk. So in addition, on a trunk port, we also might want to include some options for specific VLANs. For example, we could say in a trunk port, I want the maximum number for VLAN 123 to be 50 MAC addresses or 100 MAC addresses. Or I want to do a static MAC address for a specific VLAN. So just be aware that when you're doing trunk configuration for port security, we do have options for adding details regarding specific VLANs so that we can implement the control we want to. For example, we may want to do port security limiting of 50 MAC addresses for VLAN 123 and maybe 500 MAC addresses for some other VLAN. And we can do that by including the VLAN information, the VLAN keyword, in our configurations when we're dealing with a trunk interface. There's also some options with port security for aging. For example, if we're doing dynamic learning, do we want to age those MAC addresses out of the CAM table as secure MAC addresses based on inactivity timeouts or based on an absolute timeout? Those are some additional options we have when setting up port security. It's now time for our assessment check. Go ahead and take a moment, answer these questions, and then we'll review them together. How many MAC addresses are allowed by default regarding port security? And the answer for that is numero uno, just one by default. Question number 2, what is the default violation action? Is it protect? Is it restrict? Is it shut down the port or shut down the VLAN? And the answer is yes. It is one of those. It is shut down the port. It'll put that port into an error disabled state when a violation occurs. That is the default violation action, is to shut down the port. Question number 3, which attack can be prevented if we implement port security? And the attack that we mentioned in this nugget is a CAM table overflow attack that we can mitigate and reduce the risk of that happening by implementing port security. And then question number 4, when will we go through the demonstration for implementing port security? And that, my friend, is in the very next nugget. Our boss approaches us and is worried about, oh my goodness, I heard about these CAM table overflow attacks and hackers eavesdropping on all the frames. We can say, you know what? No worries. We can mitigate that using a feature called port security. If you and I told our boss that port security can be used to help mitigate or reduce the risk of a CAM table overflow attack, it's not just talking about the technique of port security, it's actually implementing it. So in this nugget, you and I are going to take a look at the commands that we can use to both implement and verify port security to mitigate and reduce the risk of a CAM table overflow attack. So without further ado, let's go directly to the command line of a Cisco Catalyst switch. So let's have some fun with this. I've got switch 1 and a Kali Linux box, and what we're going to do is we're going to go ahead and launch an attack. I'm going to use MacOff. The -I simply says go ahead and launch the attack over Ethernet 0, and I am connected via SSH to this Kali box. So the control channel between us and that little Raspberry Pi running Kali is over wireless. That's how we're connecting to it, and then it's plugged into a switch port on switch 1. And now let's go to the switch and let's ask the switch how it's doing. We'll do a show MAC address table count for VLAN 123. The Kali box happens to be plugged into an access port on VLAN 123. And the switch is saying, my life isn't so good right now. It's getting very dismal, in fact. And I've got 5,925 that have all been learned on VLAN 123. And the Kali Linux box is relentless. That little Raspberry Pi is just pumping those out there as fast as it can. So let's go ahead and stop the attack. We'll go back up to our Kali box. I'll do a Control-C to stop the madness. Now back on the switch, let's go ahead and configure port security. Now I am remotely connected to the switch. I'm not on the console port. So what I'm going to do is turn on terminal monitor so we can see log messages as they're being sent to the VTY session that I'm on. Next, we've got interface gig 0/2. That happens to be the port that the Kali box is currently connected to. So it's Ethernet 0 on the Kali box and gig 0/2 on the switch. And although it's already been done, I'm going to do this to demonstrate its importance. I'm going to specify that this port is an access port specifically. Again, we cannot have switch port security. It won't work if we have a dynamic port. It needs to be an access port or a trunk. Next, I'm just going to make sure that this port, this access port, belongs to VLAN 123. Again, that may have been done previously, but I want to make sure it's correct. Next, let's set the maximum number of MAC addresses that are allowed to be learned on this port. Let's set it to 5. I think 1 is really, really strict. For example, you could have virtual machines with different MAC addresses running on your computer. So I think anything less than 10 is probably not malicious. So here we'll set it to 5. And that means that the 6th MAC address learned on this port will go ahead and trigger a port security violation. And while we're here, and because we can, let's set up the aging parameters as well. Let's tell the switch that for this port, we want to go ahead and age out after 5 minutes, and we want to do it based on inactivity, not an absolute timer from the first time we learned the MAC address to aging it out, but rather 5 minutes of inactivity. Now next, we have a violation mode to deal with. Now the default violation mode, do you remember what it is? What does the switch do by default if there's a switch port security violation? And if you're saying, Keith, I know it does a shutdown of that port, you would be absolutely right. So in this case, let's go ahead and set up the restrict option instead of the default shutdown option for the port. And to do that, it's switch port security violation restrict. And if we wanted to add a single static MAC address, we could do that as well as one of our 5. So we can do that with the command switch port security MAC address, and then the 12-character MAC address that we want to go ahead and have the switch know about on that port. Next, this is the part that I often forget. After all of these switch port security commands that we've done, those are all just parameters. We have to still enable the feature. And the way we enable the feature is with the command switch port security enter. and that actually turns on the feature, and they'll start using all the parameters that we specified. So let's take a look at the configuration on this port, which is gig 0/2. So it's an access port. Again, it cannot be a dynamic port. It has to be either a trunk or an access port. It's been assigned to VLAN 123. The maximum number of MAC addresses is 5. So the 6th MAC address learned on this port will trigger a violation. That violation will be restrict. The aging time is 5 minutes, and that's based on 5 minutes of inactivity. And there is our static MAC address that we configured on this port. If we want to see the address that we've configured without having to do a show run or a show run interface, we could just issue the command show port security address, and it will tell us. Right there's the address that we configured. It's on VLAN 123 because that port is an access port for VLAN 123. And it shows us the port. That way it kind of gives us a bird's eye view of any hard-coded secure MAC addresses that we have with port security. Another option is we could do a show port security for the entire box or for a specific interface to see the details regarding port security. So here's our current port security status of enabled. Now if this showed disabled, it's very likely because we forgot to issue the command all by itself, switch port-security in that interface. It's currently up. We have not had a violation, and even if we did have a violation, the violation action is to restrict, not to shut down. And there's our violation mode right there. We have the 5-minute inactivity for aging out MAC addresses that were dynamically learned. There's also an option for static addresses that we've configured to be aged out. And we didn't enable the aging out of static addresses. So that's why it says disabled here. Here we have the maximum number of MAC addresses, which is 5. If we do want to enable sticky learning, we do so with this command, switch port security, MAC address sticky, and that turns on sticky learning. So let's get out of configuration mode. I'm going to turn off terminal monitor as well with terminal no monitor. And now let's go ahead and launch the attack. In fact, I want terminal monitor on so we can see the benefit of those syslog messages that the restrict violation option is going to give us. So we'll turn terminal monitor back on so we can see those messages. And now let's go launch the attack. We'll go back to our Kali box. I'll hit the up arrow key. And we'll launch MAC off again using Ethernet 0. So now that that's flooding, if we take a look back at the switch, we have these port security violation messages coming up saying it's happening, and here's the last MAC address I saw that triggered it. And fortunately, there's a little interval in between, because if we had some customer sending tens of thousands of bogus source MAC addresses, which Kali Linux is doing right now, by the way, we wouldn't want to have our screen just overtaken with those messages. So let's go ahead back to Kali Linux. I'm going to do a Control-C to stop that madness. Let's go back to the switch. And let's do a show port security. Take a look at the details of what's happened. So this is a great picture of what's going on. So it looks like port 6 has port security configured. And port 6 looks like it's using the defaults with a maximum of 1 MAC address. Currently it doesn't know about any MAC addresses. It's had no security violations. And the violation action is shut down. That's for port 6. Now our Kali Linux box, which is on port 2, the maximum number of addresses that are supported are 5. It currently has 5. One of them static, the other 4 are dynamic. And it's had 28,913 security violations in the short time that we were running MAC off against it. And the action is restrict, and that's why the port didn't get shut down. Now on port 6, let's say that port 6 was indeed a trunk, and we wanted to go ahead and do port security on that. Well, to do that, I'm going to first go to that interface and say that you're going to be a trunk. I'm going to specify the trunk encapsulation and the trunking mode of on. And then I'm going to set port security with a maximum of 50, but just for a specific VLAN of 123. And again, most of the options as they relate to port security, when we're working with trunks, we can tag on the VLAN identifier that we want to work with or apply to so that we can implement the type of port security that we want and with the numbers that we want that are specific to a given VLAN. So here's our trunking encapsulation, here's our trunking mode, and this says the maximum of 50 MAC addresses regarding VLAN 123. And the switch port security actually turns on the feature. And it is time, my friend, for our assessment check. So take a moment. If you need more time, just pause the music and answer these questions, and then we'll review them together. Good luck. Well, my friend, how did you do? Let's take a look. Question number 1. Why does port security prevent CAM table overflow attacks? And if you said, Keith, that's easy. CAM table overflow attacks are limited because we're limiting at a port-by-port basis the number of MAC addresses that can be learned by the switch on that port. You'd be absolutely correct. That's one of the features of port security. Question number 2, which option places MAC addresses into the running config of the switch? And when I think of the answer to this, I think of a Cinnabon at the airport. Sticky, sticky, sticky. It is sticky learning that puts a MAC address that's been learned into the running config. And then question number 3, what type of switch port can't use port security? And if it's a Cisco switch with a license that supports port security, there's a possibility of not being able to use it if that port is a dynamic port. It cannot be a dynamic port. You have to set it as either a trunk port or an access port, but it cannot be a dynamic port. And that would be a situation when we can't use port security on a switch that otherwise supports it. So, my friend, how did you do? If you got 3 out of 3, I want you to put your right hand in the air and say, "Oh yeah." And if your coworkers are looking at you, you can just say, "Oh yeah," one more time, and then let them know what you're doing. Because, my friend, it is absolutely okay to celebrate our success as we watch, learn, and conquer together. Because we realize that just hoping that a CAM table overflow attack won't happen against us isn't enough, in this nugget we've walked through the steps systematically for implementing and verifying port security on a Cisco Catalyst switch. Hey, thanks for joining me in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.